how do we find the critical value of z, or t for that matter, when we're working with levels of confidence? So the exercise is asking us to find the z-score, or actually I think it's the sample size we need for a 90% level of confidence. So what we're going to do is we're going to look at our z-score table, and if I'm looking for the middle 95%, okay, I'm looking for z-score numbers cut off that middle 90%. Okay, and then that means if there's 90% in the middle, there's 100 minus 90% on the outside, and we're going to divide that by 2 because this is the because it's symmetric distribution. Okay, so 10 divided by 2 is 5. So there's 5% of this distribution will fall in either tail area, right? And since we're dealing with probabilities rather than percentages, I'm going to rewrite those as 0.05 and 0.05. Now our table only tells us area to the left. That's why that's blue. So what I need to do is I need to go inside the middle of this table and find a probability that's as close as I can get to 0.05. And that would be that z, alpha divided by 2 value they're talking about. So if I go inside the table, I'm looking for as close as I can get to 0.05. I'm seeing 0.050 and 0.0495. So it's somewhere in between negative 1.64 and negative 1.65. And since this is a symmetric, and for this kind of problem, this isn't bad. I mean, this is symmetric. To me, it's 5 above what I want on the left and 5 below on what I want. So I'm thinking that the actual value I'm looking for will be right in the middle, so 0.05. So what I'm asking myself is, what's in between 1.64 and 1.65? Well, it'll be halfway between. If I can just add that value, I ignored the negative because this will be exactly the same on the upper tail too, right? That's because there's the symmetric probabilities. So if I go with this z-score of 1.645 in my calculation, that'll help me find the number that cuts off that lower, the lower 5% of the values at the bottom of the 90% values. Okay. Now this is a lot of work to do each time to have to go in this table, and SUllivan at the bottom of the table of the second page of this normal curve table gives us some shortcuts, and these are some pretty common values. They aren't all here, but so I'm seeing for a 90% confidence interval, there's the 1.645 you were just talking about. Okay, so that's where it comes from, and how we can then go ahead and use it and do some calculations. Hope that helps and what you were looking for.